y'all. My name is Kel Hanna. I'm the Chief of Curation at Cactus Consulting Group. As developers and tech professionals, I'm pretty sure you all are familiar with solving for unknown quantities. And as fate would have it, Tobias McNulty is out with a sore throat and unable to give his talk today. Cacti are known for withstanding some extreme and sometimes unpredictable conditions, and our team is a manifestation of that enduring quality. So we adapt and we support each other. Tobias has asked a few trusted people to step in and deliver his presentation, and they graciously answered the call. Co-presenters Kenya Phelps, a software engineer at Cactus, one of my teammates, and Ahmad Faturi, great friend to Cactus and a senior software engineer, will deliver today's talk on behalf of Tobias. So next, I'm going to tell you a little bit about our co-founder and the creator of this presentation, and then pass the mic to them to get to the good stuff. That's Tobias. He is one of the co-founders of Cactus. And started using Django in 2007. Cactus is an employee-owned Django-first consultancy based here in Durham. We support the full life cycle necessary to design, build, and maintain custom solutions for clients with a special affinity and talent for Python, Django, and mobile app development. We're proud to own a building right around the corner from the convention center, and we'll be hosting sprints at that location starting tomorrow. So if you are still around, please do stop in and say hello. During Tobias's time, starting with Django, he's a big advocate for the contrib.messages. He's also a member of the Django ops team. And he spends a lot of his time in our offices most of his full time designing cloud-based and on-prem infrastructure for Cactus clients. And also he helps keep my crazy ideas grounded. In his spare time, he bakes amazing bread and grows vegetables. And if you're ever lucky enough to try some of his bread, you won't regret it. At this point, I'm going to turn over the floor to Kenya Phelps to get to the good stuff, talking about celery.
All right. This is my first tech conference, and this is my first talk. So please be gentle, okay? All right. So a couple of questions. Don't we all like polls? How many of you are familiar with Celery? Good, good. How many of you are actively using Celery on a project? How many of you are using Celery Canvas? And last question, how many of you are here for more Celery cooking ideas? Excellent. So I saw quite a few hands go up, and I'm a software developer, 2.5 years experience. And I just have a quick story about, like, you guys saying, you know what Celery is. I didn't know what Celery was when I first started. I got to spend some time with a senior developer working on in some code base, a legacy code base. And we were working on a ticket, and I was just so excited that he had the time and the patience to help me through some problem solving. So, as a junior developer, I come prepared, and I'm writing my notes down furiously because he's talking, and I'm like getting into it. I know what that means. I know what that means. Oh, don't know what that means. Let me write everything down. And then at the end, he's like, yeah. And then, we're trying to, I think the issue is a celery beat and whatever. I'm like, wait, did he say celery? And then he says something about a rabbit. And I'm like, okay, let me write these things down. They don't sound technical, but I'm gonna write it down. Okay. And so he gets done. And I'm like, okay, Joel, you said celery. Did you mean celery? Because he was like, oh, I absolutely meant celery. And I'm like, well, I don't know what that is. And so we did a deep dive, and no pun intended, going down that rabbit hole on the rabbit too. We did that, and it was actually amazing because I felt like this I understand. It's easy to grasp this concept, and I loved him for doing it. So I'm glad that you guys knew what celery was because I certainly didn't know. So just wanted to share that little blurb with you. Thank you so much for indulging me. So let's hold on. Oh. I can't see yeah. Oh, my note thingies is not. Yeah, but okay. Thank you. So our talk today, thank you, Ahmed. Our talk today will be broken up into two parts. First, getting started with celery. And in part one, we'll talk about what celery is and how to add it to a Django project, how to choose a message broker, how to choose a task scheduler, and how to run tasks on a predefined schedule. The last thing we'll talk about is how to choose a results store, and it won't be Target, okay? Okay. So then in part two, we're going to focus on a case study in which we can explore various ways of breaking down large tasks into smaller ones that scale more easily, what we are calling good tasks. So we will also briefly summarize some of the celery patterns and anti-patterns that we learned. So getting started with celery. What is celery anyways? So I was supposed to insert a bad dad joke in here, but I don't have a bad dad joke for what is celery, so insert your own. The Celery homepage says that it's a distributed message processing system with a focus on real-time processing. That means, in a nutshell, Celery is a means for executing tasks in the background, potentially on a large number of servers in parallel. Some of Celery's major features include support for running code that is triggered by but outside of the normal request response cycle in Django. It communicates with a message broker, which is responsible for handling the work, and it can be configured to run tasks on a periodic schedule, so it can act as a cron job replacement. Because it can run code outside of the request response cycle, it is its own workers. It can help make sure requests are timely. And then it is reasonably good at distributed computing and high availability. So when it's configured with multiple workers on different servers. Celery remains immensely popular. We've written several blogs about it at Cactus over the years, and we're really pretty famous for our blogs, real famous. This consistently remains one of the highest traffic pages on our site, and sometimes by an order of magnitude, okay? There are other options for message processing and background tasks with Django, but we think that Celery is a solid choice. And there's a good chance other Django developers like yourselves will have heard about or used it in other projects, which we already know since the poll. Yeah, we know that you do. All right. So some specific use cases where Celery is valuable. It's generating assets, for example, different image sizes. So after uploading a large file, notifying users, for example, when surveys opens at a specific time during the day, updating the search index for a large content site from time to time, or running maintenance tasks, so backups or cleaning up old files, database records that aren't deleted on their own. Adding Celery to a Django project, pretty straightforward, relatively simple. How many times have we heard that, right? I just said that in my mind. You need to install the package, okay? There is some boilerplate, so it should be, like I said, fairly simple. Celery, or you can search Celery first steps with Django in any of your favorite search engines. You need to import the app instance in your project's top level init py file. Remember, top level. I made the mistake of not inside. And we don't want to go down that road, right? So that's configured every time the Django runs. And before we can use Celery to run any task, we also need to configure it to use a message broker. The message broker is a task queue that allows the workers to consume the task. These workers might all be running on the same machine or potentially on different servers. The two most common message brokers used with Celery are RabbitMQ and Redis. Tobias recommends using RabbitMQ. I technically don't have a preference now, and I haven't had, but Tobias does. Except for smaller projects where you already have Redis deployed and want to avoid adding a service dependency, RabbitMQ is purpose-built to be a message broker, and it excels at that task, per Tobias. It's highly scalable and it's very efficient. It comes with a built-in admin dashboard, like Django itself, and it provides visibility on different queues. So if you decide to use Redis as a broker, some of the caveats to be aware, and these are also documented in the Celery documentation. Tasks that are not acknowledged within the visibility timeout will be redelivered to another worker. Example, executed again. The default visibility timeout for Redis is 1 hour. While you shouldn't have a task that is running this long, if you do, you'll likely be quite surprised to see it getting executed again and again and again. If you forget to increase the visibility timeout, that's going to be the output. Now, while you might be tempted to simply increase the visibility timeout, its purpose is to protect against task loss in the event a worker crashes, or in case of a power loss. So increasing visibility timeout has the downside of prolonging the time before interrupted tasks will be rerun. So it's really not a solution. You're just prolonging the terror because it's going to be terrifying when you have this go on, run. So other more nuanced caveats include key injection and group result ordering. If you would like to use Redis as a broker, we recommend familiarizing yourself closely with these pages in the docs. Really pay close attention to those pages. So wealth of knowledge. In summary, we recommend using RabbitMQ whenever possible, possibly falling back to Redis if it's already deployed, and the caveats are acceptable on that particular project. Once you've selected a broker, you can configure it into project settings.py file with the Celery broker URL setting. As of Celery 5.3, we also recommend setting the Celery broker connection retry on startup. Now that we have a Celery configured, we can start writing a task. A Celery task in Python function that is wrapped with the task or shared task decorators. Here we have a task defined called batch password reset emails, and it takes a list of user primary keys to send password reset emails for. You might queue this task, for example, when an admin user selects user accounts to activate in a web interface, but you don't want to wait to send all of the emails at once before returning a response back to the user. Here in our staff activate view, we might have a form that figures out which users the admin select to deliver invites to. Then we obtain those primary keys and pass them into the delay function on our Celery. Task, batch, password, reset, email. Say that really fast. Then you can use the messages framework to save a status message for the user and redirect back to the staff list page. When delay is called, the web process will deliver this task with its arguments, the message broker, and then return immediately so the status message can be queued and the HTTP response returned to the user. In the Celery worker process, almost immediately, if there's an open worker, the task will be picked up and the emails will be sent out. Voila. Here is a workflow diagram of the different processes and messages. In the Django lane in orange, the HTTP request is received. Then the Django view calls the task delay function and then returns the HTTP response. RabbitMQ in teal receives the AMQP and then passes it off to a Celery worker running in another process. The Celery worker in blue then sends the necessary emails or whatever the workload might be and records the results if needed. Queuing tasks manually covers a large number of use cases, but sometimes it's helpful to be able to queue on schedule as well. Celery Beat is the name of a feature in Celery that is responsible for scheduling tasks at predefined times. It doesn't run tasks itself. Instead, it adds tasks to the queue so the workers can pick them up and execute those. It's worth noting that Celery Beat is optional, so don't go willy-nilly adding stuff into stuff. Don't go adding it if you don't need it. If you don't need it to run tasks at specific times of the day, you don't need Celery Beat. We don't want senior developers getting on you, okay? Celery Beat is built in Celery itself, but like a lot of packages, it comes with a couple of pain points. One of those is that it requires state. By default, this is kept in a flat file, which can be annoying and maintain in our modern container-based deployments. The second is that you should only ever have one Celery Beat process running at a time. Otherwise, you might end up with 2 copies of the same task getting executed or scheduled. I'm sorry. There is a separate app called Django Celery Beat recommended in the Celery docs that allows customizing the Celery Beat configuration specifically for Django projects. It includes an optional task scheduler that allows you to use the Django ORM to track state. Django ORM, yes. And it also comes with a Django admin interface, so you can monitor Celery Beat tasks via the admin, and we love the admin. So the installation steps for Django Celery Beat are similar and also straightforward. You install the package via pip, and those are the installation instructions. While Django Celery Beat supports configuring task schedules in the database, Tobias still recommends storing those in your setting files. I also recommend it. I don't know if, so he does too, I do too, whenever possible with the Celery Beat schedule settings. Please note that some older versions of Celery supported a setting without the first underscore in this name, so be on the lookout for that if you're copying, pasting code from the internet, please. To define a scheduled task, you give it a name. You point the task or function to be called and define a schedule, either here in a period of seconds or in cron syntax. Once a schedule has been defined and you have a Celery worker and Beat process running, you will start to see the output from this debugged task in the Celery worker logs. If you ever need to return values from the Celery task, it's also worth configuring a result store. The result store is responsible for keeping track of the return values from task functions so they can be retrieved async either by other tasks or web requests. For simple use cases, a better pattern is used to update the database and to end the task. But for more complex workflows, you might need a result store to keep track of the results as you go. There are many potential result stores you could use. Over 17 the last time Tobias checked, but I checked too this morning and it was still 17. But since we're using Django, we recommend starting with the Django ORM. Redis works quite well as a result store, so while we don't recommend using Redis as a broker, it can absolutely be used to store the task results. So, and just to talk about that a little bit, that was confusing to me as a beginner developer because it's recommended for this particular technology is recommended for one thing and not the other. So you might want to dive a little deeper in the docs for that because that took a couple of go arounds for me to understand that. Just to point that out, and not to say that it would for you, but for me it did. Like Django Celery Beat, there is a Django Celery results reusable app you can add that includes a custom result and cache back in for Celery. It also uses the Django ORM and comes with Django admin interface for observability. So the installation instructions are similar and pretty straightforward. You need to install the package, add the app to the installed apps, and configure the 2 settings in your settings file. We didn't quite, okay, so full disclosure, this is something that Tobias is saying. I love this about him. He is being completely just, vulnerable. Full disclosure, he's like, we don't quite understand how these short strings work, Django DB and Django Cache, the first time we saw them, but we believe that they are mapped behind the scenes. So in the project setup.file, to entry points or classes within Django Celery results source code. So don't come for us. We already said we're not sure how everything is working under the hood, but we know that it works. Now that we have a result store configured, we'll be able to fetch those results of our tasks that are finished executing. And that's my part. Now for the good stuff, good tasks. I want to introduce Ahmed, and he's going to finish it off.
My name is Ahmed Bituri. I come all the way from Libya. I had to take 4 different flights just to be here. I'm really thankful for Cactus. They sent me an invitation. I was really happy, and I want to thank them for making this happen. So I'm here. This is my first DjangoCon and my first talk too. So we'll see how it goes. All right. So, picking the right size task. One of the hardest part about designing good tasks is fine-tuning the amount of work done in each task to best balance readability, scalability, and maintainability. Sometimes low-running tasks are easier to write, but might be harder to debug when something goes wrong. On the flip side, really short tasks, for example, less than 1 second, might come with an undue amount of message overhead if scheduled in the high volume. Ultimately, the goal is to design around units of work that are small, but not too small, and that can be executed simultaneously. Another good criterion to use for designing task size is how graceful shutdown will be supported by your application. So for Kubernetes, the default timeout of graceful shutdown is 30 seconds, and for supervisor, it's 10 seconds. These can certainly be increased, but I would not increase them indefinitely. In any event, if your task does not wrap up work, either by finishing what it set out to do, or by somehow saving its place and queuing another task to pick up where it's left off later, it will be terminated and might leave its work in an inconsistent state. To help supporting building the right size tasks, Celery supports a number of primitives of grouping and chaining tasks. These can be combined to support arbitrary complex workflows. Before tasks can be chained or grouped together, however, we need a way to bundle tasks function with its arguments so Celery knows how to call it. Celery calls it the signature. And it can be created with the S function, which takes as its arguments, the arguments that you want to pass to it is the task when it's eventually executed by a worker. Typically, this would consist of a JSON representation of the function that needs to be called along with its arguments. Once you have a task signature, you can pass them into the chain function to execute them sequentially. The return value for previous tasks will be passed to the next task in the chain, and so forth. Similarly, the group primitive can be used to queue tasks all at once and run them in parallel. In this case, all the return values from a group tasks will be collected together in a list. A task group can be part of a larger chain of tasks, so you can For example, chain the list of results from a group into another task to aggregate and report on the results. Finally, there is also a star map function, which can be used to pass a list of arguments into a task, which will be executed sequentially for each set of arguments. We'll talk more about this in the specific example shortly. There are other primitives you can explore in the Celery docs linked here. As a general rule, try to avoid passing state from one task to another through task results. Instead, just as you would pass an object primary key into a task instead of the model object itself. Try to minimize the size of importance of arguments passed to tasks in the chain. As Mr. Flavio went into more details on this in his Celery talk yesterday, and Tobias recommends checking out the video if you didn't have a chance to see it yesterday. To help understand how these Celery primitives can work together, it's helpful to explore an example together in code. As some brief context before we do that, Cactus has been working as a software development team for the High National Election Commission in Libya since 2013. And this is actually the same time as I have met Tobias, too. It's like 10 years now. Libyan citizens registered to vote by SMS, and Cactus team built their voter registration system using Python, Django, and Celery. One function of this application is the generation of voter rolls. We think it's a good case study that we could use to explore how Celery primitives works. If you'd like to follow along in the companion repo, here's a link on the GitHub repo. It's cakt.us/Celery-code. While this code is based on the idea of voter rolls, I should mention it was written from the ground up for the purpose of this talk, so it's not actually used to run any elections. If you would like to see a running code for elections, there's an open source project that we have worked with Cactus for. It's called Smart Elect. You can navigate to that, Smart Elect. So the general goal of the code is to create lists of all eligible voters for distribution on paper at the time to all the 2,000 polling centers in Libya, 2,000 plus. In a nutshell, the code assigns voters within each polling center to groups of 500 to 600 voters, which is called a station. So this is the largest number of people that could reasonably be handled by a single desk or a table in a polling center. For example, there might be anywhere between 2 to 30 stations in a center, depending on the population density around that area. After splitting voters into stations, the code generates PDFs, one for each station, with the list of eligible voters in that station. So there are a lot of different ways we could write this code. And Tobias wrote up several of them in the example repo. If you're looking for the code, it can be found in the voter roll /rollgen.py. So let's talk through each of these options now. In option 1, all the code is executed in a single Celery task. We do iteration through all the polling centers in the database. For each center, we split the voters in the center into reasonable sized stations. Then we write a voter list to a PDF file. Along the way, we keep track of the total number of pages written and print summary at the end. This is short and easy to understand, but it's not ideal for a couple of reasons. All the work done here is sequentially. The work can't be distributed to multiple workers in your configurations. It takes longer than 30 seconds, even though we have given it a sample file of 10,000 fake users. Fake voters. A natural way to break up this work might be to go through each center one by one and writing all the PDFs files for that center in one task. So this is option 2 here in sample code. What it does, it splits the voters into stations only for that specific center. And then it writes all the PDFs files for each of that stations, for each of the stations. And at the end, it returns the total number of pages for all the stations within that center. We continue on option 2, and this is the second task. We need a task or a function to kick off all the individual centers level tasks. We can do that with the Celery primitive called group. So group task takes an iterable of task signatures, what you get from the S function, which can in turn be called as a group with delay, the delay function, to add a task for each center to the queue all at once. The work will be processed by the workers up to the total number of workers in parallel. You might be tempted then to wait for the task to complete and gather up the results. Do not do this. This is not good practice. For one, it is not possible or even advisable to wait on a task within another task. And for number 2, you will hold the process calling join, doing nothing. The join function here will be doing nothing until all the other tasks are complete. So instead, this is option number 3. We can, option number 3, we can chain or pipe the results of the center level tasks into a final core task that has the job of summing the page counts from the other tasks and reporting them. This task is virtually instant. It queues all the tasks with group as before and tells Celery to kick off the task sum pages task once the tasks in the group are complete. According to the Celery docs, the synchronization step is expensive, so this model should be used sparingly, but sometimes it is unavoidable, so it's still better than the alternative of waiting synchronously for all the tasks to complete. Note you may also see the code function here. It's doing the same thing as the pipe syntax, but we use the pipe syntax to be more explicit, just to be more explicit and easier to understand. And this is the following function for task number 3, option number 3. Here's so it takes the list of the results from all the tasks in the previous groups, then calculates and prints the sum of those page counts. So option 4, as a brief tangent, instead of splitting voters into stations one by one, we could do all the parallelized work up front. This turns out to be a bad idea. Why? Because work is relatively fast anyways. It even might be slower, highly parallelized, with all the Celery messaging overhead. And we don't want to pummel our database with too many queries at once. So this is a database-intensive category of work that is often best done synchronously. If the code is too slow, time is probably better spent on optimizing the underlying database queries, rather than simply trying to do more things at once. In this case, trying to execute all the queries in parallel would almost certainly takes more time rather than less time. So in option 5, we modify the task to accept 2 parameters, center ID and station ID. And the work it contains is limited to generating the list only for that single station in the polling center. In this demo, the running time for this task is between 7 and 8 seconds, which is an ideal for Celery tasks because it simplifies graceful shutdown. Now, you might be pursuing the Celery docs and see promising-looking helper function called starmap. If you're familiar with the Python multiprocessing library or the map or the other map reduce type of workflows, you might think that Celery, being the distributed systems that it is, would execute tasks in parallel when called with starmap, but this is actually not the case. Here, and noted in the docs, starmap queues only a single task and runs each subtask sequentially within that task, instead of in parallel like the group function. So the performance of this version is really the same as what we did in option number 1, which we did all in one task. But the code is harder to read. Tobias wasn't sure what the use case is for starmap. So if anyone happens to know, we would love to hear about it during the Q&A. Option 5B, our last and final option, we return to using group to queue and one task for each center ID and center station ID pair. Then we pipe the results into the task sum pages core task. This option gets database work out of the way quickly, and then parallelizes the CPU-intensive work. Again, anecdotally, this particular unit of work takes around 7 to 8 seconds, sorry, which is a great length of time since it's less than the default graceful periods of Kubernetes and supervisor shutdowns. In other words, when a Celery worker is told to shut down, for example, when new code is deployed, we can be confident that it will finish the task it's currently running, and then exit before consuming any more tasks. If you'd like to try out the code, please check out the companion repo for this talk. And you can use the included management commands to generate some test data and run the various tasks. Watching the Celery worker outputs will provide some insight into when and how tasks are run in parallel, when they're not, and how long the various options take to complete. To summarize, some patterns we like to recommend for Celery on Django projects are to first use RabbitMQ as a broker whenever possible. When ORM objects are needed in a task, pass the primary keys and fetch the objects in the task. Use Django Celery results and Django Celery Beat database backends for visibility and ease of use if you need those features. Divide the work into right-sized tasks. A good target is for all tasks to be complete within a graceful shutdown period. The don'ts here are just don't make a task that waits synchronously for another task, and don't write a task that takes longer than your graceful shutdown period to complete, and don't massively parallelize database operations or other work that derives no benefits from running in parallel. If you'd like to learn more, Cactus has several popular posts on the Cactus blog about Celery, as cactus.us/blog/Celery. Last but certainly not least, yesterday at DjangoCon, Mr. Flavio gave a pre-recorded talk on mixing reliability with Celery for delicious async tasks. His talk focuses on some more advanced use cases for Celery and suggests additional options for tracking state in more complex workflows. So we recommend watching video after the conference if you did not happen to catch it yesterday. Thank you for coming to our talk about Celery, and we are happy to engage in conversations about this talk, and you are also welcome to reach out directly to Mr. Tobias via LinkedIn or Mastodon. Thank you.